So hi everyone, my name is Urvin and this is my video for demonstrating my task 4.0 OP for SIT329. So the project is a smart monitoring system for a farm environment in which I am using the Nano 33 IoT and the DHT22 temperature and humidity sensor along with two alarm LEDs. So let me explain the hardware first. So here you can see is the Nano 33 IoT and the whole circuit in which DHT22 is connected. LED 1 is at D4 which corresponds to A group PA07, and then we have LED 2 which corresponds to D5 which is the PA05, and then comes the DHT22 which is on the pin D2 of the Nano 33 IoT. So let me explain the alarm conditions now. So what is happening is the temperature alarm has three states. So as you can see when in through the serial monitor that when the temperature is 10 degrees Celsius or higher, the LED 1 is off. When the temperature falls below 10 degrees Celsius, LED 1 blinks at a rate of 1 hertz. And then if the temperature falls below 4 degrees Celsius, the LED 1 blinks at 10 hertz. Similarly, the LED 2 corresponds to humidity. When humidity is below 50%, it blinks at 0.5 hertz frequency, and below 30% it stays continuously on. So these are the thresholds according to the task. So let me explain the software timers now. In the software time, so here you can see the software timers. So the system uses four independent software timers. The poll timer has a period of 5 milliseconds, which controls the main polling loop. And then the sensor timer controls the DHT22 sampling rate. And then LED1 timer controls the temperature alarm blinking accordingly. It uses 500 milliseconds for 1 Hz condition and 50 milliseconds for the 10 Hz condition. So similarly, it goes for the LED2. And now and let me explain the GPIO driver here. So the role of GPIO control is that I'm using the GPIO Deakin class, and instead of using the Arduino's digital write, read, the class assesses the port registers directly of the Arduino Nano. And for example, the dir set is used to configure an output, and outset and outrear are used to set the output as high or low, and out toggle is used to toggle the LED. So these are the different types of registers that we are controlling. So this allows LED control to operate at the SIMSYS register level as required by the task. So let me explain the main loop now. So here comes the main loop in the INO file. So this is the main program using the polling, and the loop first checks the first 5 milliseconds poll timer according that I have explained in the software timer. If the timer has not expired, the loop returns immediately. And when the timer expires, the program checks whether sensor timer has expired. And if it has, then the DS222 is read and the temperature and humidity alarm status are updated and printed on the serial monitor. And after that, LED1 and LED2 functions are called on every polling tick using the latest sensor states. And according to that, the actual loop implementation follows the sequence: poll timer, sensor timer, and then comes the LED and LED2 alarms. So this was the whole project, and you can see the serial monitor in which the temperature state and humidity state are being visible, and along with that it shows that the LEDs are off because the state is 0, and beside that there is the readings, percentage of humidity and the temperature value in degrees Celsius. So this was the whole project that I have demonstrated according to the task, and here you can see is the provided hardware. This one is the DS22 Nano and the two LEDs. So this was the whole setup. Thank you for watching.